Hey everyone, thanks for checking out this video today. We're gonna talk about similarity. We're just gonna touch on the definition of similarity and some introductory concepts of what it means. So two polygons are similar if they have the exact same shape, just a different size. So the formal definition, polygons are similar if the corresponding angles are congruent, so that means equal in measure, and the ratios for their corresponding sides are proportional. That sounds a little confusing, and we'll talk about that in a minute. The symbol for similar triangles is just the tilde, so similar to the congruent symbol. So if you remember the congruent symbol, that is this, and similar is just the top of that. So congruent is kind of the similar symbol plus an equal sign right underneath it, where similar is just the tilde. So a visual example that I'm going to have here and kind of go through what all these symbols that I drew in here mean. So if we have ABC and DEF, and I say that triangle ABC is similar to DEF, so this means that the corresponding angles are congruent. So angle A has to be equal to angle D, so let's make both of those 90. It says angle B has to be congruent to angle E, and it says angle F has to be congruent to angle C. So that's what it means to be similar, the same angles, so it's the exact same shape, just a different size. So now what does it mean when it says corresponding sides are proportional? So that means if I take AB, this side length, this measure here, and I divide by ED, that should be the same as when I take AC and divide by DF. So let's look at what that actually means with numbers. So let's say let's say AB is 5 and ED is 8. So what it's saying is that 5 divided by 8, because that's AB divided by DE, 5 over 8 has to equal whatever the length of AC is divided by the length of DF. So let's say we knew the length of AC was 10. 10 divided by the length of DF. Well, I could find the length of DF here, right? By cross multiplying. So I could do 5, let's make DF like X or something, just some variable. So DF equals X. So 5X equals 10 times 8 is 80. So X must be 16. And you might have been able to see that just by kind of doing the math in your head, but 5 over 8 has to equal 10 over 16. So that must be 16. So that's what these corresponding sides are proportional means. It implies that the EDF triangle is the same multiplicity of the BAC triangle every time. So it's 8/5 times as big. So let's look at one more side. Let me do an easier example here. So what it really means is that let's say that this is 510 again, and let's say that ED is 10. What I've done is I've taken BA, I've multiplied it by 2. What similar means is that that means every side must be twice as big as ABC's. So that means that DF must be 20. That means that EF must be twice as big as whatever this is. Let's say, well, we could do the Pythagorean theorem. We probably have to here. So 10 squared, this would be square root of 125. So this must be 2 square root of 125. That is what similarity means, that this is the same ratio for all side measurements. So triangle DEF is twice as big as triangle ABC, but they are similar because they have the exact same angle measurements and the same ratios for corresponding sides. So they're proportional throughout. So that's what it means to be similar, same shape but different size. So hopefully that makes sense. We'll get into some more numerical examples in a minute here. Let me know if you have any questions, and thanks for watching.